So, practice number 2. Problem 1 on Tree on CCLE. So I have a professor with 2 books. So first thing here is I need to have a Markov chain model for this problem. So let's say xn would be the number of working lengths. Of the name. So the state space here is either no block, 1 or 2. Alright, so 2. Okay. So if they both burned out, then they will be replaced. So next day we will start with 2 working blocks. In other words, if I start from 0, following day I land at 2, probability 1. Suppose when both are working, one of the 2 will go out with that probability 0.1. That means if I start with 2, then the following day, either I go down to 1 with this probability 0.1, or I stay at 2, probability 0.9. And of course, they don't burn out the same day. So when only one working, it will burn out with that probability 0.2. So 1 will go to 0 with 0.2 probability and will stay at 1 with probability 0.8 and 0. Yeah. So the diagram will be something like 0, 1, 2. So 0 goes to 2, 2 stays at 2, go there 1, 1 stays at 1, and then good. 0. Right? So, it's pretty clear that the chain is irreducible, periodic, and well, a lot of things you can say about this, right? So the first question, what is the long run fraction of time exactly one bug working? All right. So part A. So how do I convert that into the technical term, right? So that means so state number 1. So recalling the notation n sub n1, right? Is the number of time. Is the number of times k is equal to 1 or k is equal to 1 to n. Recalling this can also be called as this summation with the indicator function. Indicator function say 1 here. Evaluate at the value of maybe this is maybe better. Okay. about in the long run, the fraction of time only one bulb working is basically I'm asking for the limiting behavior of this ratio. And the answer will be pi 1, where pi is the unique stationary distribution. Stationary distribution on this is because I am invoking the result that I'm invoking here. I have if, well, I guess I'm invoking the fact that I have what is the theory that I'm invoking? I can say I plus as pi, right? And plus the current altogether will imply negative y over n will convert to yeah. That is part A. Now, part B, what is expected time between the light bulb replacement? So what does it mean when I say so the time between the bulb replacement? Way to replace the bulb is because both of them are burned out, right? So stay here, start from 0, 1, 2. Let's say suppose I start at day 0 with zero working bulb. Start from here, then the next day I will jump to 2. Because I replaced both of them, right? And then whatever it does in the following days, not replacing it, not here, right? So this is this time here, bulb being replaced here. Yeah, all right. So then whatever here, and then until the first time we will hit 0 again. So this is T0, right? And then when it hits 0 again, for the first time, then I'm going to replace the bulb. So the following day, I will replace the bulb again. So this is T0 plus 1. So here, bulb being replaced again. Right? Yeah. So basically they are asking for, well, depending on your interpretation, but for me, basically that means I am looking for the difference between this time and this time. Right? So that is the time between bulb replacement. Yeah. So here, so this time, so this all the way up to here. This is the time between between replacement. Yeah. Does that make sense? So that they're asking for the expected time, right? What is expected time between both replacement? So that, well, you guys can already see the random variable that I am looking at is basically t0. That so this is expected value starting from time 0, t dot expected time between replacement. Yeah, I mean technically I should have say starting from 2, I guess, but then from 2 here I go all the way up to this. So the length is still the same as starting from 0 going to t0, basically. The length is still the same thing. Yeah. And according to the result that we have this, expected value is 1 over pi evaluated at 0. Yeah. So recalling the result that we have, if I have irreducibility plus s pi, then I y is given by 1 over expected value of yt. Yeah. So let me move on. I do have the other problem, but that is, the solution is in the note that I posted on TCL for problem number 2. Okay. So you just in case you have any difficulty, just take a look at so problem number 2. Solution is in the lecture note. Now let me move on to the next section here, 1.8. There's some for exit distribution. Right. Let me already the example up against the rooming. Recall this, if you're rooming, I have xn is the number of total cash after playing and games, right? And games. And the state space is 0, let's say up to $4. So maybe just a $3, the same thing. So just like so either I have to stop at $0 or I got to stop at $3, right? So what is the matrix here? 0, 1, 2, 3. 0, 1, 2, 3. Alright. So this is 3 here staying at 3 forever. 0, 0, 0. If I hit 0, I stay at 0 forever. And 0.4, 0.6, 0.4. All right. That means that I will lose $1 with this probability, and I will win $1 with this probability. Yeah. So I believe that is the first example that I discussed at the beginning of the course. So I remember I proposed the problem following asymptotic question. Eventually, broke. Yeah. I hope you remember that question. What is the probability that eventually I will be broke? So now, given all these notations that you have, I guess you're already familiar with. So let me just, well, of course I gotta start from somewhere at the beginning. And so this is the same actually, same as V0 is V infinite, right? What is the probability eventually I will hit 0 infinite time? And if I start from $0, what is this probability? It is 1, for sure, right? It is 1. On the other hand, suppose I start with $3, what is this probability? Zero, right? Because if I am I'm already rich, it can never be broken. So 0. Yeah. So now the next thing is what happens if I start with either $1 or $2. Right? So now for x being either 1 or 2, I want to know where we're starting from x. V0, V infinite. Yeah. And so the idea over here is the so-called one-step analysis. Alright, so this so-called one-step analysis. Okay. And I will mention the theorem in the moments, but for now, let me just be a little bit sloppy without any really rigorous proof. Okay. So the probability of being broke can be actually rewritten as, how is it possible I could be broke? That is the same as saying, axiom, I will hit 0 before I hit 3. So if I hit 0 before I hit 3, that means I am broke. Okay. Yeah. And so this, of course, if the V0 is finite, that does also imply the V3 has to be infinite. Yeah, it has to be infinite. If this guy is finite, then this guy has to be infinite, for sure. So now one-step analysis is basically I am considering what's going on in the first step. So this could be thought as what, V0, right? I hope you still remain given x1 is equal to z, x0 is equal to x, I have p x z. Of course, I am assuming on z in my state space because I'm considering what happens in the next step. So of course here, I mean this state space only has four states. So this can be if z being what? If z being 0, right? with Z. Well, I mean, technically over here, from X here, I can only go down or up. So technically, that's the same as V0 less than V3, given X1 is X minus 1, X0 is X, P X minus 1, right? It can only go down or it can only go up. So let me rewrite again. X1 be X plus 1, and X0 be X P X plus 1, right? So only two possible jumps for X between and or X either one of the two, right? Okay. And so now I'm going to invoke the Markov property. So I will forget the past, only condition on the current state. So this is equal to, this is equal to, so I will condition on this, x minus 1, so we have x minus 1, b0 less than b3, multiply with x going to x minus 1, plus x plus 1, b0 less than b3, px. Yeah. And so now, if I have to write down in terms of a system of linear equation, right? So let me denote following h of little x, so maybe z here, to be the probability starting from z, v0 less than v3, okay? And I arrive at the following system of linear equation. So h of 0 is 1, h of 3 is 0, and so how about h1? So h1, so over here, right? This is so h1 is equal to, this will be h0 p10 plus h2 p12, and similarly, h evaluated at 2 is go down to 1, p21, or go up to 3, p23. Yeah. So a very simple linear a system of linear equations, very simple. And so now you can solve for x1 and x. You can solve for it pretty easily. Right? It shouldn't be difficult here, I will say. It shouldn't be difficult. Do I have to go through this, or are you guys good? That is stuff. You know how to solve it? Yeah. Yeah. Okay. So anyway, so now we can. Well, conclusion is now we can say now we can solve for the h1 and h2. Right. And so that's a beautiful rule. So we call it h1 is h1 again is the probability starting from $1. Eventually I will be broke. So b0 less than, and then h2 is probably starting from $2. So less than. Yeah. Pretty handy, isn't it? Pretty handy. Any question about the approach? Any question on that? So this is the so-called the exit distribution. That means eventually I will have to exit and be absorbed, I would say. So note that here, not the state number 0, sorry, state 0 and state 3 are called absorbing states. The name absorbing already tells you what it means. Once I hit these states, I will stay there forever. So they absorb the Markov chain into a trivial path. Okay. So, what is the result that I want to mention here is following term number 1, which is a generalized inversion of the theorem 1.27. If I remember correctly. Let me just check. Likely. Yes, 1.27. So given the following, given A, B, C joint set, just that following holds. S, it can be written as a union of A and B and C. Okay. And with the condition that, the key condition I would say, C is finite. Alright. Given 3 disjoint sets where C is finite. And of course S is the union of these sets. And furthermore, let me suppose for all state little x in the set C, the probability of x of BA wet, BB, B infinite is positive. Right? So this is the minimum, look at the above there. So A wet B is the minimum between A and B. Okay. So that means, so starting from X here, I gotta know that the first time I hit either A or B, will have to be finite. This probability is strictly positive, right? The first time I hit either A or B. So BA wet with BB. So think about like BA wet BB can be thought as like the first time hitting, what should I say hitting? We should say visiting. First time visiting, should say union. All right. First time I visit either A or B. So I gotta know for every x and c, this probability is positive. Then let H is a function from my state space map to R. All right. Satisfying exactly that relation on this forward. Satisfying what I have H of H of Z being 1 or Z in so for all Z in the set A, H of Z is being 1. For all Z in the set B, H of Z is 0. Alright. Okay. And then for X inside of C, I have H of X is equal to basically the summation on Y in my state space S. So let's just say, I guess I'm going to go P, X, Y, and then I have okay. I just call X to be a function on the state space satisfying such relation. And the result says that this function actually exists and is unique and is given by the probability I will hit A before I hit B. So the result says then the function H uniquely exists and given by formula of Z is the probability starting from Z and B is strictly less than AB. Yes.
So if we wanted like, for say in the Gambler's Ruin, like the probability that we win, given we started a certain state, that would just be 1 minus H1, for example, right?
Indeed, yes, indeed. If you want to have, say, if I am eventually being rich, that is just a complement.
Yeah.
Basically. So, yes, yes. I guess over here I want to say, yes. So, suppose probability like into Gambler Ruin, right? So, eventually, which is probability that I gotta hit 3 before I hit 0, and that is 1 minus probability of 1, V0 less than V3. Apparently they cannot be equal. Apparently they cannot be equal. So that is 1 minus. Cool. Alright, so the result here is actually difficult to prove, and so let's just take it for granted here. So that is, so one thing I'd like to mention is a little exercise here concerning the two keywords. First one is C being finite, alright? You have to start a finite set, and in order if you want to absorb into either A or B, and that's one is this. So actually this condition is not really that easy to check, However, if you have following some lemma, lemma 2, and suppose the following. So let me just rewrite it all over again. So S being A, union B, union C. C is finite. Of course, here they are joint. So A, B, C is joint. Alright, C being finite. suppose further that all states in C are transient. Okay. Suppose every state in C is transient. Then the conclusion is for x in the set C, probability of x be a wedge, a minimum with a b infinite. This probability is actually 1. Actually very intuitive, because suppose I start in C and I'm being transient. Eventually I will have to hit either A or B. Eventually I will have to. I cannot just evolving inside of C forever, provided C is finite. If C is infinite, that is possible. If C is infinite, every state in C is transient. Starting in C, I could stay in C forever. And so we have to include this crucial condition. Let me start with let me just mention the proof list. This is not really given in the book. It's number 2. Okay, so by means of contradiction. Wow, contradiction. Let me assume there exists an x in C. Is that that's what B A minimum B infinite is constant little c, which is strictly less than. Yeah. Let me just assume that. So what can I say? So step, I guess I want to say step number 1, I guess. So now for all n, maybe I guess for all n, but I have p and x z. This summation on the little z inside of S. What is that summation? What is it equal to? If I sum every z 1. Because step number n, I have to hit somewhere. So this one. Alright. So I can decompose this summation into the summation on z inside of the set C, p and x plus the summation of, let's say, y here, inside of the union of A and B, P and x1. Right. Yeah. So I'm gonna call, let's say, for the sake of notation, simplicity, let me call that some being. D sub n, depending on the step. So over here will be called E sub n. So eventually we'll have to arrive at some contradiction. So now step 2. On one hand, what can I say about the summation on the inside of the set C, which is my Dn? So because I'm going to invoke the assumption now, since are states, and C are transient. Alright, I have P and X, Z converging to and Z transient. What is this limit? 0. And here, right? Also, C is finite. Implying if I take a sum, P and X, Z, this finite sum, right, will converge to 0. Finally, so this is my release, right? That's crucial. If you have finite sum, each of the term going to 0, then the finite sum will have to go to 0. But if you have an infinite sum, then you cannot really say anything. You cannot say anything. So, that's what does that imply? I have Bn plus En being 1. Right? So I have En being what? 1 minus Dn. This will have to go to 0. Sorry, to go to 1. Okay, so that is one observation. Okay, so now step 2, step 3, concerning the sum, the En, the sum on the A union B. So I have En being the summation of y sub A union B, which is Pn x y. This is the probability of starting from little x and hitting A union B, right? The probability that as the step n, I visit A or B is basically equal to this probability summation. Right. However, if that does occur, if that occurs implying probability of x BA minimum with BB, yeah. If I know I hit A and B at the step number n, then the minimum, the first time you hit either A or B, gotta be valuable by n. And of course, this is trivially valued from above by BA with BB being finite. Yeah. So what is it? Here. This is a C, strictly less than 1. Which is a C, strictly less than 1. This is a contradiction hypothesis. Okay, so what can I say now about En if I take the limit?
Goes to something less than 1.
Yeah. So if I know what short is bounded above by the little c less than 1, the limit of En will have to be bounded above by c strictly less than 1, which is a contradiction. On one hand, I already show En going to 1. On the other hand, En is going to some c strictly less than 1. So that is a contradiction. Contradicting En going to 1. Okay? Yeah? Alright, so we'll kind of finish a little bit starting.